Hey guys, welcome back to part 10 of this endless runner game tutorial series in Unreal Engine. And in this video we are going to fix some issues related to our platforms, and also we are going to set up our inputs in a proper way rather than using those key events. So stay tuned till the end of this video, and also you can download this whole project from our Patreon, so you don't have to make the whole game yourself and speed up your process. All the links are in the description. Now as of now, our obstacles and platforms are spawning pretty well onto this road path, but here is one issue. Like if we jump at the side on this platform, you can see how our player literally goes inside it and it don't dies or anything, it just overlaps inside the platform. So we need to fix that. So for that, let's open up your base platform BP. Now since this is a base class for the platforms, it of course doesn't have any mesh or something because that's inside its child class. But just for the demonstration, let's give it the respective mesh for now. So for the ladder mesh, we have this, and for the platform, we are gonna use this wooden platform. Now if our player side jumps into this platform, we can detect that by placing a collision box here. So let's add a box collision component here, and let's name this death box. Now we need to scale this along with the platform. And to scale this, we are gonna use this box extend value instead of normally scaling it. So like we will have proper measurement of the scale. Now let me scale this a bit in the y-axis. I'm gonna keep its value to 100. Now let's place this near the platform to get the idea of the scale. Now there is one issue, like the length of the platform is not constant. So even if I try to scale this box collision on the x-axis, it's not going to match the length of the platform. But at least I can scale this in the z-axis. So let's do that first. We are not gonna cover the whole height, just leave some space at the top and the bottom. Now to scale this in the x-axis, first we need to place this box at the center of the platform, and once we did that, we can scale it perfectly from there according to the length of the platform. So to place this at the middle of the platform, so for that let's go to your construct script, and here you see this for loop which adds platform one after another. So when this for loop completes, that's when we are going to set the position of our death box. But how we gonna set it to the center? So for that, we are going to add the starting of the platform with the ending of the platform and then divide it by 2, and that will give us the center point. So let's do that here. So here let's get this last platform at H point, which is the ending location of the platform. And to get the starting of the platform, we can get it from the ladder mesh at H point, which should be somewhere here where a platform starts. And to get that location, get the ladder mesh and here search for get socket location, and the socket name is at H point. So now we are going to add both of these locations. There you go. And since we added the starting of the platform and the ending of the platform, there is one more thing to notice here, that we have this extra part that has been added. So after that addition, the location value should be somewhere around here. Okay, so now let's break this vector, and here we are going to divide this x-axis by 2. And that is going to give us the center location of the platform. Okay, so now let's set the death box to that location. So get the death box and search for set world location. We are going to do that after the loop completes. Now right click on the parameter and split the structure and plug this divided value to the x-axis, and meanwhile we want to keep the y and z at the same value. So get the world location of the death box, right click and split the structure and plug y to y and z to z, and it just copy the same value the death box already have, and it only changes the location of the x-axis. And now if you go to the viewport, here you'll see the death box is at the center of the platform, and even if the platform length changes, it always calculates the center of the platform and set its location there. And now we can scale it on the x-axis according to the length of the platform. So to scale this, what we are going to do is, we are going to subtract the end location of the platform with its start location, and that will give us the distance between these 2 points, means the length of the platform, and we can use that value to scale this box. So get these 2 values again, and here we are going to subtract this end point with this starting point. So subtract them, and then let's break this vector since we only need the x-axis. Then get the death box. Now we are going to scale this box using this box extend value. And to do that in the blueprint, from the death box search for the set box extend. There it is. And let's split the structure and connect this vector x value to set the box extend. Meanwhile, to keep the y and z value same, get the box extend of the death box, right click and split the structure, and from here connect y with y and z with z. And we are setting the x value at the center of the platform. And now just connect the execution pin and let's go to viewport. And here you will see the box is a lot bigger than the platform, and that's because both the half sides of this box are equal to length of the platform. So we need to divide it by 2 and then it will scale perfectly according to the length of the platform. So here just divide the x value by 2 and plug it here, and there you go. And now you can see the death box size is perfectly aligned with the length of the platform. So once we are done with the scaling, now we can detect if a player has side jump on this platform. But before that, select your death box and in the details panel, search for the hit event and select this generate hit events option. Because for this death box, we are going to use on hit event instead of on begin overlap. Because through the hit event, we can get more idea of from where the player has hit the platform. Now first of all, what we are going to do is, when anything hits this collision box, first we want to ensure that it is a player character. Okay, so now we need to know like from which direction a player has hit this platform. Either from this direction or this, because the hitting direction should always be opposite. Because let's say if your character is running on the platform and it rolls and moves side and it somehow touches this collision box, your character might die. So to avoid this condition, we should know the direction of hit. So here let's break this hit structure, and from this you will get all the details about that hit event like location, time, distance and all that. But here we want this normal vector because this normal vector is perpendicular to the face and gives the direction of the surface where we hit. So let's break the vector. And here the perpendicular vector is y here, as you can see here. So it's going to give us the hit value in the y axis. So just for testing, let's print this value. Now before we play, select your death box and set this collision preset to custom, and here block the pawn, which is our character, otherwise the hit event won't work. Okay, so if we hit the platform from the right direction, we get the negative values, and if we hit from the left direction, we get the positive value, and that's what makes the difference here, the negative and positive value. So let's remove this print string, and here we are going to round this y-axis value, so that we will straight get either negative 1 or positive 1. And from this search for switch on end. And set the start index to -1, so that when we add the pin, it starts from the -1 and we need it till the positive 1. And now here, since we know if the value is negative, that means we jump from the right side, and if it is positive, that means we jump from the left side. But here, how we are going to ensure that the player has jumped from the opposite side, not the same side. So for that, we can check that the player is playing which animation while he hit the platform, and it could be any of these side jump animation. So to check the condition, here let's get a branch. So here, if the player has hit the platform from the right side, then he must be playing this side animation. And if he has hit from the left side, then he must be playing this one. Now to get what animation a player is currently playing, we can get it from this player character reference. Just search for get current montage, and then we can compare it with the respective side jump animation. So in this case, the player must be playing this side jump animation. So select it here, make sure you have selected it, and plug this to the condition. So if it is true, that means we have actually hit the platform from the opposite direction. So we can call death event after this. Plug it to the true condition, and since this is the interface, we can just give it this character reference because we have defined this event in the character blueprint. Now what if the value was 1? So in this case, the animation montage that we must be playing should be this one. So select it here, and if that is true, the character is going to die. And if you were moving in the same direction, the condition would go on the false. So now let's play and test this. So here let's hit the platform, and we have a weird glitch here. Here our character has died, but for some reason our camera was clipped. So to fix that, here select your platform mesh, and in the details panel, scroll down, and here change the collision preset to custom. And all you need to change is set the camera to ignore, and do the same with the ladder mesh. So now your player's camera won't be blocked by these meshes. Now we did those for the meshes that we added manually, but what about those we added at the runtime? So for that, go to construct script and come to this part where we are adding these platforms, and right after we add the platform, here we are going to change the collision for the platform that we add. So from the return value, search for set collision response to channel. There it is. And here we want to change collision for camera and set it to ignore. And that's it. Now the camera clipping issue must be resolved. Alright, so now let's try to hit the platform from the side jump. And there you can see our character dies and there is no camera clipping problem. But there is one more issue here. Like if I side jump and quickly roll, here you'll see we again get the same problem. And that is because the condition was for the side jump, not the roll animation. So a simple solution for this would be to also check if either we are rolling. So let's get an OR operator here. So if any of the condition is true, then our character is gonna die. Now here check if you are currently playing the rolling animation. So from here select the rolling animation and plug this condition into the OR operator. Now we're gonna add the same condition down here. There you go, and now it must fix the issue. Now here one more thing we are gonna do, that as a player hit the platform, we are going to force it in opposite direction. So to do that, here from the character reference, we can get the mesh, and to this mesh we can add impulse. Now since we want to add the impulse in a specific direction, so make vector to get all the axes separately. And here we wanna add impulse in the y-axis, and we are going to get the value from right here, from this round normal value. So let's multiply and let's give it any big number and make sure it's a negative, so the impulse will be in opposite direction. And there you go. Now let's play and test this. So here I try to side jump and roll, and our player still dies. So it's working great. Alright, so now what we want to do is, to show you that, let me go to our floor BP, and here just for the demonstration, let me add a child actor. And here let me set this child actor as a wooden platform. Now by default this platform location will be at the spawn point, and since the length of the platform is random, it can even go outside the road mesh. Although it doesn't matter since we add new road just next to it, but still what we want here is, we want to stick the end location of this platform to the endpoint of the road mesh. Somewhat like this. And the only location change must be reflected at the front of the platform. So let's try to write such a code in a construct script. Later we will move that code to the event graph, but just so we can see that in the editor, for now we are going to do that in the construct script. So what we are going to do is, we are going to subtract this attach point with the end location of this platform, and that will give us the distance of this gap. And once we get the distance, we are going to add that distance in the platform location, and that is just going to fill that gap from the behind. And that's how the end point will always stick to the end location of the road. But to do that, we must have the end location of this platform, right? So that we can manage it with the attach point and get the distance of the gap. So to get the end point of the platform, get the child actor, and inside that get its child actor, which is our platform, and then we need to cast it to a base platform BP. And once we cast it, then we can access this last platform attach point, which is the end location of the platform. But there is a way we can avoid this casting and access this value. So for that, let's go to your platform BP, and here let's add an arrow component. Let's name this attach point, and we want this attach point at the last point of the platform. So for that, here after you set this last platform attach point variable, so after this, get your arrow component and set its world location, and its location is going to be this variable. So get this variable and plug it here. And now you'll see this arrow component is always at the last point of this platform. So now what we can do is, in your floor BP, we can access that arrow component. Just here get component by class, and the component we want to access is the arrow component. And now it will find any arrow component in this blueprint, which is this. And as we get this, we want to get its world location. Just like that. And here what we want to do is, we are going to subtract this attach point with the platform endpoint, and we will get this gap distance. So here get the attach point and get its world location, and then split this structure, same for this one, and we are going to subtract the x-axis here with the platform's endpoint. X-axis because there the gap distance is in x-axis, like here you can see it. So subtracted with the platform's endpoint, there you go, and with this we'll get this gap distance, which we are going to add at the front here. So it will fill the gap from behind. So let's add this distance, and we are going to add it with, like from this child actor, get its world location, which is basically our platform's world location, and add its x-axis with that gap distance. And then set the world location for the platform. Here let's split the structure, and for x, plug it here to this whole calculated value, and the x and y is going to remain same. Now just connect the execution pin with the construct script, and let's see how it works. Now as you can see, both the platform and road ends at the same point, and like no matter what the size of the platform is, it's still going to stick to the end of the road. Now since we know this code works, now we can move this to our event graph, and we are going to paste it here where we spawn the platform. Just like that. And here we are going to replace this child actor with this child actor that we add at the runtime. There it is. And now let's delete this child actor from this flow BP since it was just for the demonstration. Now let's play and test this. Now here I can already see the difference since platforms are always not at the same place. Like sometimes they are forward or backward because of the length of the platform. Alright, now it's time to set up inputs in a proper way. So let's open up your character blueprint, and here you can see like we are using these key events to take the inputs from the player, and that's not any proper way to do that. Instead, we are going to use this input action. So you can search for IA_move, which is this input action event. And this input action already comes set up with the third person template. Like if you go into your inputs folder, here you will find this. It is the event that we are using here. And all the keys binding to this input action are all set up in this input mapping context. Like here you can see all the keys, WASD, up, down, and all that. So all these keys are responsible for triggering this event. And to differentiate between inputs, we have this action values. Like here if I press the D key, this X value is going to be positive, whereas if I press the S key, the X value is going to be negative. And the similar way for the vertical wise, we have this Y action value. So this way we can differentiate the direction we want our character to move to. Now just to show you how this value works, let me print this action value. Let's print the X value first. So if I press A, the value is negative. If I press D, the value is positive. Now the similar way, print the Y value. If I press W, the value is positive. If I go down, the value is negative. So now you know how it works. So hold S and click to get the sequence. And we get this because we want to check two conditions at the same time. So get a branch. The first condition is if this X value is not equals to 0. It's just like a filter so that we'll only get the value that are either -1 or +1. Now from this X action value, we want to convert it to integer. So for that, search for truncate. Well, it just kind of rounds the value towards 0. So after the filter, we'll straight get either -1 or +1. So search for switch on int, and we're gonna start it from -1 and add the pins 2 times. So depending on the value we get, the respective pin will fire. Alright, if the X action value is -1, that means we want to move left, and if it's +1, then we want to move right. So here what we are going to do is delete these key events and let's replace them with the custom event. Let's name this one move left, and the similar way delete the D key and create a custom event and name this move right. And here we are going to call the respective events. Move left on -1 and move right on +1. Now let's copy this and paste it down here since we want to check the Y action value at the same time. Now we need to do the pretty much same thing for the Y value. So delete this S key and replace this with the custom event. Call this move down. And same for the W key. And name this move up. And call the respective events here on the respective values. And now we are done setting up the inputs. So let's play and test this. And here our inputs are working completely fine. So that is it for this part of this tutorial series. If you really like this video, you can support me on Patreon, where you can get all the project files I've ever created for these tutorial videos. The link is in the description. And you can also join my Discord server, where you can interact with other developers of this community. And if this video really helped you out, you can like and subscribe to my YouTube channel. And I want to thank the Patreon members of this month. Thank you so much for your support. It means a lot. Alright, till then, see you. Bye bye.